If you were around at the turn of the millennium, you probably have at least a passing familiarity with the Sony MIBO. This virtual pet given physical form was all the rage when it released back in 1999, and for a good few years after. Even if you've never seen an MIBO in person, which is honestly pretty likely seeing as the cheapest model cost $1,000 at release, you've almost certainly encountered one of the many other robot dogs that followed in its wake. One such dog is the topic of today's video. This is MIBO, a robot dog made entirely from LEGO and powered by not one, but two LEGO Mindstorms RCX bricks. As a kid, I thought this was the ultimate LEGO set. A massively complex Technic automaton containing the highest end parts you could get at the time, and which was no doubt unobtainably expensive for all but the richest of rich kids. Several months ago, I got back into LEGO Mindstorms and remembered about the giant robot dog I saw in magazines as a kid. I went looking to see what the current going rate for it was, only to discover that no such set was ever actually produced. It also wasn't a combiner model, which I thought it might be owing to the multiple RCX bricks. In fact, it wasn't even designed by anyone at LEGO. MIBO is the creation of Jin Sato, a Japanese-Canadian software engineer who designed and built robots on the side. He started working on MIBO in 1999 after seeing an early demonstration of the Sony MIBO. The MIBO hadn't been released at that point, so he decided to make his own version with LEGO Mindstorms. MIBO was an instant hit with the Mindstorms community at the time, and was featured by multiple websites and publications. However, I cannot for the life of me figure out where I saw it when I was a kid. I have a distinct memory of seeing MIBO featured alongside marketing material for the Mindstorms Robotics Invention System. However, it doesn't appear in any of the ads or catalog listings I can find. It also isn't featured in any issue of LEGO magazine from the time, not even in the section where people send in their own original creations. It also doesn't appear in the Ultimate LEGO book that my elementary school library had. MIBO was featured on the official LEGO Mindstorms website at one point, but that was when I was far too young to have my own computer or be using the internet much. So I genuinely don't know where I saw this thing or how I was convinced it was an official set. Either way, I wanted one when I was 8, and I still want one today. But now I'm an adult with disposable income and unrestricted internet access, so I actually have the means to do something about it. If you watched the video I released back in February, which I know you didn't, because almost no one did, then you'd know that I spent a couple months re-implementing the functionality of the Mindstorms RCX brick on a modern microcontroller. Everything I did in that video was ultimately in service of creating my very own MIBO. The custom Super RCX I designed was made specifically to replace the two RCX bricks that powered the original MIBO, hence doubling the number of motor and sensor connections while trying to match the original RCX in size. As for everything else, that's where this book comes in. Jin Sato's LEGO Mindstorms: The Master's Technique. This book contains all the information you need to build your very own MIBO, written by the designer himself. There's complete building instructions, a parts manifest, printed source code, advice on where to find the parts, and even how to store and transport the finished model. What's really crazy is that MIBO is just one part of this entire book. LEGO Mindstorms: The Master's Technique is a complete guide that contains just about everything there was to know about Mindstorms in 2002. There's a section dedicated to general LEGO building techniques, there are comparisons between all the different LEGO motors and Mindstorms hubs that existed at the time, including a full teardown of all 3 RCX revisions, there are programming guides for all the major Mindstorms IDEs that were around, there are full guides for multiple projects, complete with source code, there's a complete breakdown of the RCX's internal bytecode format and the transmission protocol used by the IR tower, and if all that wasn't enough, there were multiple chapters dedicated to building LEGO models in CAD software, and then making your own instructions using the limited 3D rendering tools of the time. This book is an insanely comprehensive reference, and a lot of the information in it is still useful almost 25 years later. The entire thing is up on archive.org, so I'll drop a link in the description in case you want to go read it for yourself. Now, this book was originally published in Japanese and later released in English. While the English version is more complete, I do have one pretty big gripe. There's mention of a revision to MIBO's design made since the original Japanese publication. This revision replaces the dual chain drives on MIBO's hind legs with gear trains for increased reliability. Unfortunately, this change is not reflected in either the parts manifest or building instructions. There's not even a clear photograph of the new gearing mechanism, even though there is one of both revisions sitting side by side. For this reason, the earlier chain drive version of MIBO is the one that I'll be building, though I may attempt to implement the changes from this revision myself sometime in the future. I also sent Jin Sato an email asking for more details on updated MIBO revisions, along with a few other questions I had. Unfortunately, my message came back undeliverable, because the email address I have for him is from the early 2000s, at a domain that's been offline for who knows how long. When it came to actually building MIBO, acquiring all the necessary pieces was by far the longest part of the process. I already had about a quarter of the parts I needed in my existing LEGO collection, and I was able to get almost all the rest from a single order on Weebrick. Those last few pieces, though? Well, getting my hands on all of them took quite a while, and ended up being a bit of an adventure in a couple cases. I'm gonna go through all the weird and rare pieces this build requires and how I got a hold of them, starting with these concentric ring gears. This style of gear is not particularly uncommon. They tend to show up in larger Technic sets, though most sets will only include 1 or 2 of them. MIBO requires 7. The reason these were hard to find is that LEGO revised their turntable gear design sometime around the early 2000s, and MIBO uses the older style of gear. The only version of this piece LEGO has sold in the past 20 years lacks the studs to connect standard bricks, and has the Technic pin connectors in a different position. An original studded turntable gear goes for around $5 online. Including shipping, that's upwards of $35 for just 7 of the over 800 parts I need to gather. Thankfully, there's one company called Polyroyal who's still manufacturing clones of the old ring gear design. Thanks to them, I was able to get these brand new for about $2 each on AliExpress. It's a similar story with this gearbox piece. It was discontinued by LEGO sometime in the late 90s, but you can still get brand new ones from Polyroyal. MIBO only requires 2 of these, which is the amount I ordered, but for some reason they sent me an entire bag of gearboxes. I guess that's better than not having enough, but I'm not really sure what to do with the rest of these. 2 pieces I was surprised I had to hunt for were these 1x8 plates with holes in the end, and these wing plate pieces. These fairly basic parts, that I know I've seen in quite a few sets, were apparently both discontinued years ago, and have not been resurrected by GoBricks or any other boot LEGO brand I can find. I was able to track down a couple of these parts at a local used LEGO store, but the rest I had to order from Bricklink with the associated shipping charges. There's also the additional motors and sensors I needed, which have not been cloned and I had to get from Bricklink. No surprise there. I have heard that this style of 9-volt motor tends to go bad, but all the ones I have, both from when I was a kid and that I ordered for this project, still work fine. Maybe I've just gotten lucky, but I really hope these motors can keep working, because if they do go bad, I don't think there's anything newer I can replace them with. That leads me on to the rarest and most expensive piece this build requires, the 9-volt micromotor. This might be the most obscure motor LEGO has ever released. I didn't even know these things existed until I started working on this project. The micromotor was produced between 1993 and 2001, and only ever appeared in a tiny handful of high-end sets, a few of which were never sold at retail. As a result, these motors are extremely rare, and a large number of them are no longer working due to being over 30 years old. When I first learned about this piece, I thought this whole project might be dead in the water. I absolutely did not want to go forward with a large project that's reliant on such a rare, expensive, and unreliable component. Thankfully, one of the no-name Chinese companies that makes clones of the LEGO Power Function system has created their own Power Functions micromotor. I was able to get one of these brand new for just $7, and it's only slightly larger than the original 9-volt micromotor with the cable attached. The only downside is I'll have to get an adapter cable for it, but that shouldn't be too difficult. Or so I thought. Yeah, turns out LEGO 9-volt cables are kinda hard to come by these days, and they would be the most expensive piece MIBO requires if it weren't for that micromotor. In my last Mindstorms video, I showed how the rubber coating on most of my 9-volt wires was disintegrating, and apparently that's a problem that plagues all 9-volt wires made before around 2005, which is the vast majority of them. The 9-volt system also hasn't been cloned the way Power Functions has, so any wires that have not yet begun to deteriorate are rare and expensive. I figured it would be significantly cheaper and more practical to build my own cables, but that wound up being a mistake that delayed this video by a good while. I had a bunch of these 9-volt connector plates 3D printed. The way these work is that you put some sort of electrically conductive adhesive on the underside of the plate, then shove jumper pins through the holes on the sides of either stud, and finally solder it all together with wire. Inserting the pins is incredibly fiddly, but the real problem is that this plastic gets soft and deforms when you put a hot soldering iron near it. After much effort, I was not able to get a single one of my 3D printed cables working. Thankfully, I eventually found an eBay listing for a collection of 9-volt to NXT adapter cables in various states of disrepair at a not unreasonable price. I'm more than capable of splicing together a few wires, so I bought them, and now that should be everything I need to build MIBO. Between slow shipping from China and the time it took to source some of the rarer pieces, the process of gathering everything I needed for this project took months. I put in my initial Weebrick order back in February, but that didn't ship out until March, and I didn't receive the final shipment of wires I needed until it was almost May. Alright, so I just want to jump in real quick with a mostly unrelated aside. I just learned about this as I was editing the video, and it is too crazy to not mention. Recently, the YouTuber Reckless Ben posted a video about a situation with the Bricks and Minifig store in Salem, Oregon. It's a really good video, it's been going viral, you should go watch it if you hadn't seen it. But what's crazy is that I was actually visiting Salem a couple months ago, and I went to that Bricks and Minifig store to look for parts for MIBO. When I got there, I was very confused why they were closed, because everything online indicated that they should have been open. I think the sign was still up, but I didn't get a good look at it, and I read some angry reviews and a local news article about the theft, but the full story was way more insane than I could have imagined. So now I can say that this insane, ongoing saga has had a direct, albeit minimal impact on my efforts to recreate a 25-year-old Mindstorms dog. Anyway, back to the video. Now before we get to the actual build, I need to address a pretty major flaw I discovered with my custom RCX replacement. When I designed and built this thing originally, I didn't have any RCX rotation sensors to test with. And now that I do, I've discovered that they don't work with my hub. Rotation sensors are active sensors, meaning they require power to operate. You can watch my previous video for more details, but just know that reading active sensors is a lot more complicated than reading passive ones. Because they require power, I assumed the rotation sensors used an optical rotary encoder. Basically just a light sensor with a spinning disc in front of it that can be used to count rotations. If that were the case, I could probably just reuse my light sensor code and add an extension to count rotations. Turns out, these actually use a mechanism I was previously unfamiliar with, where a variable resistor is paired with a capacitor to create a predictable change in voltage over the course of a full rotation. Now there are a few possible reasons why this type of rotation sensor doesn't work with my hub. The first is that they just don't work at all, but I bought 5 of these things and I can't get a reading off any of them, so I doubt that's the issue. The next possibility is that they are working, but that the signal is so weak it's getting drowned out by the high noise floor. This is a problem I discussed in my last video and was able to mostly resolve in software, at least for light sensors. I could add additional circuitry to reduce the noise at a hardware level, but that would have to be in the form of some sort of external adapter, because this hub is not coming apart. The next potential culprit is one I wasn't aware of until I started looking into this issue. The analog sensor pins on the controller board I'm using output power at 3.3 volts, but the sensor ports on the original RCX are 5 volts. If this is the problem, it again could maybe be fixed by some sort of external adapter, and it might also explain why the light sensor can be finicky to calibrate. The final possibility is that it could be an issue with timing. The capacitor in the rotation sensor is designed to be rapidly charged and drained, and it's possible that that needs to happen at a specific frequency in order for the sensor to function. My power cycling implementation is all done in software, and while I've tried to match the RCX hardware timings, it's possible that I'm slightly off. This board also lacks a programmable hardware timer, so any time-based functions are at the mercy of the CPU, which has limited resolution and can vary a bit depending on processor load. If that's the issue, it might not be possible to get rotation sensors working at all with this design. Personally, I suspect the problem is either a high noise floor or insufficient voltage, or possibly a combination of the two. In the meantime, MIBO is not going to have any functional rotation sensors, which is kind of a bummer because those are the only sensors present in the original design. I was already planning to replace a couple of them with touch sensors, because in my experience, using a touch sensor as a limit switch is more reliable than counting rotations, but that's still going to limit what MIBO is able to do. Now it's finally time to build MIBO. The assembly process was actually fairly difficult, partly because MIBO is a large and complex model, but almost everything uses pretty standard building techniques and overall is well engineered. I didn't have much trouble putting this thing together physically. Most of the challenge here comes from a lack of clarity in the instructions. Nearly every step consists of one or more sub-assemblies that would be broken down into at least 3 or 4 steps in an official LEGO set. Seriously, some of these steps look like the exploded repair diagrams you find in appliance manuals. The instructions being in black and white also makes it tricky to tell how parts go together in certain places. I think step 9 might be the worst offender here. You have to mount a motor to the frame with a series of plates, but it's not clear exactly how they're meant to fit together, or that the motor has to be in position before you can start stacking the plates on either side. This step also requires a piece that isn't even listed in the parts callout for that step. I had to just trial and error the configuration of these pieces until I eventually got it to look right. There's also a similar error in step 14, where it calls for 2 half bushings when it actually needs 4. There's another issue with these instructions as well. The parts manifest for MIBO does not specify color for any of the pieces. I went for a combination of black and light gray based on the cover image, but I had to make quite a few judgment calls as to what color certain pieces should be. The bulk of this model is made up of 2 mirrored halves, but the instructions only show how to build one of them. They actually expect you to figure out how to build a mirror image of this massive assembly without any further guidance. I found this quite doable, but still fairly challenging. It's the type of thing that you would never, ever see in an official LEGO manual. The amount of critical thinking and spatial reasoning required to construct the second half of MIBO's body is far beyond what LEGO typically expects from builders. I ended up building MIBO's second half in parallel with the first, where I would use each completed step as a reference to create the mirrored copy immediately afterward. This is the one area where I found the challenge of following these instructions to be enjoyable rather than frustrating, but I could absolutely see this being a turnoff for some people. The first major challenge I encountered that was not caused by the instructions came when I got to the neck assembly. The 9-volt micromotor is supposed to sit in the middle of the concentric ring gear that turns the head. The Power Functions micromotor I've replaced it with is almost the right size, but it's just a little too big to fit. So I did something you're not really supposed to do with LEGO and modified one of the pieces. Specifically, I shaved down the motor by a couple of millimeters on the bottom and got rid of the 2 rear studs on top. Not exactly an ideal solution, but I don't feel too bad seeing as this isn't an official LEGO part and they can still be bought brand new. But hey, now I can use the original mount design without making any further modifications. Which I ended up doing later anyway because it's not actually all that structurally sound. The other challenge was figuring out how to mount my custom hub and 9-volt battery pack in place of the dual RCX bricks MIBO's body was designed to accommodate. My original plan was to mount the controller in place of the lower RCX brick and the battery box up top, but I found it was easier if I mounted the controller vertically in front with the battery box just behind it. This has the side effect of making everything much more accessible than it was in the original design. Originally, MIBO had to be flipped over and partially disassembled in order to access the battery compartments on both RCX bricks. But with this design, the battery box can just be lifted up and slid out on either side. As a bonus, I was also able to reinforce this part of the torso, since the top and bottom sections no longer have to come apart easily. With the guts in place, the only thing left to do is attach the head, and with that, MIBO is now complete. Jin Sato's original MIBO allegedly cost him nearly $3,000 to put together back in 1999, but thanks to the rise of e-commerce and high-quality LEGO clones, I was able to assemble this one for around $300. Now might also be a good time to mention that I do have a YouTube membership you can join if you want to support the channel. Not counting the time it took me to solder together the wires, this build took nearly 10 hours to complete, spread across 3 different sessions. A good chunk of that time was spent just trying to decipher the instructions. It probably would have been a lot quicker if I hadn't had to go back and partially rebuild multiple sections due to missing or misinterpreting certain details. I think it's also worth noting that all the information and images I've been able to find relating to MIBO ultimately originate from Jin Sato. That means that, while I'm not 100% sure, there is a distinct possibility that I'm the only person to ever build this model aside from its original creator. We're not done just yet, though. While building, I discovered this design has a few mechanical problems, which prompted me to go back and make some modifications. The first problem area is the neck assembly that I showed earlier. It uses a belt drive, which struggles to generate the torque required to turn this large gear. The real problem, though, is that the tension from the rubber band causes the drive axle to pull away, so the gear teeth don't fully engage. And yes, I did try a few different rubber bands with this. Either the axle gets pulled back, or there's not enough tension in the belt to actually drive it. My first solution was to add more mounting points on the drive side of the assembly, so that this beam can't pivot backwards, thereby preventing the axle from moving back as far. This made it a bit better, but didn't fully fix the problem. The actual solution ended up being to just replace this set of two half-height bevel gears with a single full-sized one. That pretty much solved the problem, though the turning is still very inefficient. Similarly, the axles that drive the hip gears were originally too short, which caused them to move up and down in their sockets and repeatedly slip while rotating. I swapped them out with some much longer axles and added extra bushings at the bottom to hold everything in place, making it much more reliable. I'm honestly kind of surprised that these issues were present in the final design that made it to print, because they were both immediately apparent and pretty easy to fix. Maybe they were addressed in the revised version of MIBO, but since no instructions were ever published, we'll probably never know. Though even with everything working properly, this thing is still kinda jank. All the joints apart from the neck are driven by worm gears, which causes their movements to be extremely slow, in addition to putting a large amount of torque into the drive axles. If anything impedes the joints while they're moving, all that force gets transferred backwards through the gear train, and it starts trying to rip itself apart. Even when movement is unimpeded, small irregularities in the resistance of the output gear will cause the rest of the mechanism to occasionally skip and sputter as it turns. You can even see Jin Sato's original MIBO doing this in this 2007 interview. Really, any time MIBO moves, it seems like it's on the verge of completely breaking down, and that feeling isn't helped by pieces occasionally coming loose or falling off. It seems like I'm constantly needing to reattach or resecure things anytime I try to do anything with this model. Now to be clear, most of these issues are just inherent to building a complex and intricate machine out of Lego, rather than an indictment of Jin Sato's skill as an engineer. On the contrary, there are some brilliant bits of engineering and design work on display here. I think my favorite part has to be the drivetrain for the knee joints. The motors for these are located on either side of the torso about 2/3 of the way back. To get power all the way to the knee, they first spin this long axle that goes into a gearbox. The output of that gearbox goes into another axle that rotates through the center of the radial gear used for the hip joint. The top of that radial gear is then used as a second gearbox, which outputs to a chain drive that moves power down the leg into one final axle, holding the worm gear that rotates the knee joint. This drivetrain is one of the most elaborate mechanisms I've ever seen built from Lego. It also manages to be extremely reliable, at least by the standards of this model, despite its complexity. Now, as I mentioned earlier, MIBO is supposed to use 5 rotation sensors to track how much each joint moves. But like I said, I can't actually get a reading from those with my hub. As such, I've omitted all the rotation sensors except for these 2 on the front legs, which are somewhat integral to the structure of these drive mechanisms. Instead, I'm adding touch sensors. I started by putting one on the back of the neck to track its center position. The sensor gets pressed down as it passes over the drive gear. This allows me to write a simple program where MIBO turns his head left and right before recentering it at the end. And with that demo complete, I think we're in a good spot to wrap up this video. Don't get me wrong, there's still a ton more I want to do with MIBO. I have an idea for how to add additional sensors on the hind legs, and I want to design more complex software routines for him, and maybe even get the rotation sensors working. but that'll all have to wait. While the initial build took me about 10 hours, I've spent easily double that time just tinkering with the finished model. Fixing the various mechanical problems, getting the electronics working, making sure the whole thing doesn't fall apart during that process. I need to take a break so that I can actually put this video together and release it before it gets even longer than it already is. If you've enjoyed what I've done so far though, be sure to like the video and leave a comment letting me know. If this video does reasonably well, I will definitely be putting out a follow-up, showcasing any changes and improvements I make to MIBO in the future. As always, a huge thank you to the members who support this channel. You can join them at the link down in the description, and I will see you guys later.